Yeah, very good morning to all. Today we are going to discuss about the propositional logic, which is a topic under the concept of the course name DML, that is Discrete Mathematics and Logic, which is under the second year BTech AAML branch for the SIT-RC. Okay. So first of all, let us see what is known as a logic. Logic can be defined as a branch of mathematics that deals with the verification of truth or falsity of a mathematical statements or assertions. So the scope of this logic is very high in the several applications. Okay, for example, the logic is used in the study of valid arguments. Inference means induction as well as deduction. The combination is known as a inference. And while proofing techniques and proving theorems, paradoxes, and fallacies. So different concepts will use the logic. Logic is also used in philosophy, mathematics, computer science, and everyday life are somewhat different. So our main concentration here is how we will use the logic in the that is mathematical logic in computer science and its applications. Okay. So for example, in everyday life, several problems are there. Okay. To reduce the problems caused by ignorance, we can use the logic. In philosophy, logic models the reasoning. Why study logic? Why know the truth? Okay. So like this, in philosophy, the logic find its applications. And logic is also used to remove the ambiguity. For example, some of the English sentences are ambiguous. The cat chased the mouse until it fell. This is a sentence of English. So when it will become true, okay? So that it will true only the when the mouse fell, then only cat chases. It is ambiguous somewhat. Okay. Similarly, my mother never made a cake which we hated. So why he is hating? Because his mother never made a cake. So how much it is true? The truthness is depending upon the facts which are involved in it. Like that, we can have some other examples also. Let us stop controlling people. So let us stop controlling people. Is it true or false? So that depends upon the actual situation. Okay. Similarly, in time flies like an arrow, fruit flies like a peanut. Okay. Time is just it is measured in hours and minutes, while arrow is lightning fast somewhat. So okay, these two sentences when they are becoming true, that based upon the assumptions. Okay. So like that, mathematics and programming languages are unambiguous. Okay. So in mathematics, the logic is used in to prove the theorems. In computer science, the logic is used to prove correctness of a software or hardware. The logic is used in computer circuit design. The logic is used in modeling programming languages. The logic is used in the design of expert systems, robots, artificial intelligence. So in all these applications, the logic is used. So yet in our class, we will see about the propositional logic basically. And one more thing is, there are several types of truth depending upon the sentence or depending upon the situation. Let us consider some rigors. So the truth type, word of God. Word of God belong to religious religion. Okay. The truth teller is God or priest. Similarly, authoritative truth. In the authoritative truth, it is used in the business. So we is giving this truth value. Boss. The boss is the superior in the business. Okay. Legal truth. Legal truth is either given by law or lawmaker or a judge, or it is belonging to judiciary. Philosophical truth. Some philosophy is there. We often heard in that outside with this discussion with the older people. So that truths of that philosophical statements are plausible arguments. Okay. Next, scientific truth. The scientific truth is to be confirmed by the experiments or observations that belongs to physical sciences. Statistical truth, which is based upon the data sampling. Mathematical truth, which is a branch of mathematics, can be uh, can be deduced by the logical deduction. Okay. So next, we will see the statement or proposition definition. What is a statement? The statement is also known as a proposition in English. So, proposition is a sentence for which a truth value can be assigned. So, let us consider some examples here. The atomic number of oxygen is 8, which is true. So, that's why it is a proposition. 1 plus 1 is equal to 3. It is false. So, it is also a proposition. Similarly, x plus 5 is equal to 5. We can't say that is it true or false because we don't exactly know the values of x and y here. Similarly, a into a cross b or a into b is equal to 0, which implies either a is equal to 0 or b is equal to 0. But we don't know exactly which one is 0. Okay? But either of these two might be 0. We know that one only. That's why it is also not propositional. Natasha is beautiful. We don't know the truth of this particular sentence until the person sees. Okay? So the truth value is cannot be assigned to this type of statements. So that's why these are not propositions. Gold batch conjuncture. Okay. The truth value currently unknown. Truth values changes with the time or scenarios. Today is Sunday, written on a paper slip. So today is Sunday. That is depending upon today. Whatever I am recording lecture or I am taking class for you, that is if it is Sunday, this value is truth. If it is not Sunday, its value is false. So that's why the truth value changes with the time or scenario. And logical paradoxes. The logical paradox is nothing but the statement is false. For example, this statement is false. So what the statement? We don't know exactly the statement. Even though the statement is there, we need to we need some type of logical inference in order to assign the truth value or false value for that statement. Okay. Next, we will see what is a propositional variable. Propositional variable is either a lowercase letter such as p, q, r used to represent propositions. In the previous slide we had seen what is meant by proposition. Proposition is a statement for which truth value can be assigned, either true or false. So here, in order to represent those proposition sentences, we will use the small letters P, Q, R, and S, so on, to represent them. Those are known as the propositional variables. A propositional variable can be either true or false. Algebra uses numeric values. Logic uses propositional variables. Next, we will see a compound statement. What is compound statement? In English, the compound statement is a combination of two simple sentences. In the same manner, in the propositional logic is also a compound proposition or compound statement is a complex sentence that is obtained by joining propositional variables using logic connectives. What are these logical connectives? The logical connectives used in the propositional logic are negation. It is read as a not P. Conjunction read as a P and Q. Disjunction P or Q. Conditional P implies Q. If P, the same thing is also read as a if P then Q. P only if Q. Q if P. Q provided that P. Either any of these particular cases we can represent the conditional statement. P implies Q. And biconditional. Biconditional means P if and only if Q. That is, if P is there, Q must follow. If Q is there, P should be there. P must follow. Logical equivalence. If the two propositions are logically equivalent to each other, then it is logical equivalence. Okay, these are the logical connectives. So the two sentences can be connected by means of any of these logical statement connectives. Next, negation. Already we had seen negation of a statement is denoted by this tilde symbol P, comma, is a statement obtained by changing the truth value of P. For example, P, the proposition is x is a real number such that x less than 4. What is the negative of that? X is a real number such that x is greater than or equal to 4. So we are changing the truth value. We are changing the truth value of this particular statement. Similarly, consider one more statement or proposition. The equation A44 plus B44 plus C44 is equal to D44 has no solution when A, B, C, D are positive integers. So how to change it to the negative? The negative can be obtained by the same equation as a solution when A, B, C, D are positive integers. So in that way, negation can be applied. In the negation, the truth value, if P is true, negation of P is false. If P is false, negation of P is true. Okay, like that we need to just check. We need to apply. Next, we will go for the conjunction. The conjunction is also one of the logical connective. The logical connective conjunction of two statements P and Q is defined denoted by P, this symbol. This is a conjunction symbol. P, like a conjunction symbol is like inverted V. P conjunction P is a statement such that it is true if both P and Q are true and it is false otherwise. In logical gates, we will have a one gate that is AND gate. So if we when the AND gate output is when that AND gate output is true, when so for example, this is the AND gate. Okay, so it is having a two variables P and Q. So when this output P and Q, when the output of AND gate will be so this is the output of AND gate. When it will become true, when P and Q are both are true, then only the output will be true. So similar to this particular AND gate, the conjunction is also like a AND gate. So its truth value is just true when both are true, otherwise false. Okay, so these are the examples. P and Q. P is I will get an accept from MIT. Q is I will get an accept from Stanford. So P and Q, conjunction P and Q is written as a I will get accepts from both MIT and Stanford. Okay, first statement is I will get an accept from MIT. Second statement is I will get an accept from Stanford. P conjunction Q will be nothing but I will get accepts from both MIT and Stanford. Write 0 less than or equal to x less than or equal to 1 using a conjunction. So x is greater than or equal to 0. That is one part. We have to split this one. X is greater than or equal to 0 and x is less than or equal to 1. So the conjunction of these two is x greater than or equal to 0 conjunction x less than or equal to 1. This will be logically equal to this particular statement 0 less than or equal to x less than or equal to 1. Disjunction. Disjunction of statements P and Q denoted by P disjunction Q is a statement such that it is false if both P and Q are false, and it is true otherwise. For example, this is similar to the OR gate in the digital electronics. In the digital electronics, there is a one gate is there that is known as a OR gate. Okay, that is known as a OR gate. The OR gate will be having generally two inputs, the output, one output. So the inputs are X and Y, and output is Z. Assume that when this Z output will become high, whenever any one of the X or any one of the Y is high, then Z will be high. Similar to the same thing here in the disjunction also, what happened is the true value of a compound sentence, that is disjunction, will be true whenever any one of the P or Q is true. So let us, if you consider the previous example, two statements, I will get an accept from MIT, I will get an accept from Stanford. So if you want to use the disjunction P or Q, so that can be written as a I will get an accept from either MIT or Stanford. Either you get heads or I get heads. So that is, these are the some type of examples. Next, exclusive OR. See, exclusive OR of sentence state, if you consider two statements P and Q, the exclusive OR is denoted by this symbol. P exclusive OR is defined as P or Q, but not both. So it is computed as P disjunction Q conjunction, okay, negative of P conjunction Q. So it is defined like this. That means either P is true, the truth value is true, or Q is true, truth value is true. But if P and Q are true, the exclusive value is false, because the both should not be high or low at a time. One should be high or one should be low. Otherwise, one should be true or one should be false. Okay. In English, the term or can mean either inclusive or exclusive OR based upon the context. Which OR is the this one? So, for example, consider again the same example, same case as the previous one. P is I will choose MIT. Q I will choose Stanford. P exclusive OR Q can be written as a I will choose MIT or Stanford, but not both. I get either heads or tails, but not both. Like that. Next, what is propositional form of a statement? A compound statement, what we had considered up to now, which can be represented by the propositional variables and logical connectives. So, for example, if there are two, uh, two or three statements, three propositions, P, Q, and R. So, we can represent the pre-statements by means of this second expression or first expression like this. Okay. So we can connect like this, but how to evaluate them? The evaluation will be requiring the truth tables. We need to prepare a truth table starting from the innermost parenthesized expressions, and then the next innermost parenthesized expressions, and so on. A truth table with n propositional variables will have 2 power n rows. Next, what is the precedence of logical operators? The precedence of logical operators is highest priority is negation, second priority is conjunction or disjunction, third priority is uh, implication, and fourth next followed by double implication, and for final priority is equivalence. So these are the priorities of the operators. What is priority? For example, in an expression, if there is a symbols negation and implication, first evaluate the negation, then evaluate the implication. That is the precedence of logical operators. Next, what is equivalence? In that equivalence, let us consider two statements P and Q, which are logically equivalent, denoted by P is equal to P is logically equivalent to Q. If and only if they have the same truth values for all possible combinations of truth values for the propositional variables. Okay, so this is also to be proven by the constructing and comparing the truth tables, use logical equivalence laws, etc. Next, let us consider a small problem, which is we want to show that P conjunction Q disjunction of R is not equal to P conjunction Q and disjunction R. So just select the three variables P, Q, R and assign the uh, true and false combinations for them. Since there are three variables, we can have eight combinations. TTT followed by TTF like that up to FFF. Next, whatever the terms in the parenthesis, you just evaluate the truth value. Q disjunction R and P conjunction Q disjunction R. This is left hand side. The the fourth column and fifth column will contribute to the LHS left hand side, while the next two columns will be contributing the truth values of the RHS of the RHS of the expression. So now from this truth table, we can observe that the fifth column, that is this one, is not the same as the last column, seventh. So that's why hence this expression is proved. Similarly, this is also and one more example. In this one, we need to prove that P conjunction Q disjunction R is equal to conjunction Q disjunction P conjunction R, which is nothing but associative law or distributive law. Okay. So if we construct the truth table and check the truth values of this table, so fifth column is LHS and eighth column is the RHS. Both are same. That's why this uh, expression is proved. Next, we will see what is known as a tautology and contradiction. Tautology is a statement form that is always true regarding regardless of the truth values of individual statements substituted for its statement variables. Tautology is a proposition which will always be true, okay, regardless of the truth values. Contradiction is a statement form that is always false regardless of the truth values of the individual statement. For example, if we consider disjunction negative P disjunction negation of P, whose value is always true. So that is a tautology. Similarly, if we consider P conjunction negation P, so this truth table is this truth value is 0 always. That is false. So that's why it is a contradiction. So this logical equivalence, we are having some rules, that is laws, commutative laws, associative laws, distributive laws, identity laws, negation laws, double negation, idempotent, unibond laws, De Morgan's laws, absorption laws, negations like this. So these are the formulas you have to keep in mind because this will be useful in solving a problem specific to this particular cases. These are very simple because commutative, that is interchanging of the propositions simply with respect to a variable or logical connectiveness. Associative laws. So associative laws, if three variables are there, the Grouping, it is nothing but grouping. So the two variables plus one third variable, or otherwise first variable and uh, remaining two variables. So like that, we need to group with respect to the operators. Distributive laws. So as the name suggests, the outer side connectiveness is distributed to both of the inner propositions. So like this, and remaining also will be following. So these are somewhat better to be remembered. Next, conditional statement. In the English, we are having a statement that if then a statement. If something, if case one is there, name. If case one is there, then only case two. If case one is true, case two will be following like that. So conditional or implication, it is also known as the implication represented by the arrow symbol. Conditional or implication is a compound statement of the form if P then Q. It is denoted by P implication Q and read as P implies Q. It is false when P is true and Q is false, and it is true otherwise. Okay. So for example, if we, in mathematics we are having one formula, this formula is for that solving of quadratic equation b square minus 4ac. If the b square minus 4ac is greater than 0, then ax square plus bx plus c is equal to 0. This is a quadratic equation, has two distinct real solutions. So when this quadratic equation is having a two distinct real solutions, whenever this first condition is satisfied. Similarly, write all polynomials are differentiable. As an implication, if p is a polynomial, then we can say that p is differentiable. Like that, we need to check this conditional statement. Next, in p, for example, consider this sentence also. In p implies q, p is called hypothesis or antecedent or premise, and q is called conclusion or consequence. P implies Q is called conditional because the truth of the Q is conditioned upon the truth of P. P implies Q is also called if P then Q. P only if Q. Q follows from P, not P unless Q. P is sufficient for Q. Q is necessary for P. Like that. These are all different types of uh, just implications which are identical to P implies Q. And what is the intuitive meaning of P implies Q? It is like a promise. If P, then only Q. Under what circumstances is that a promise kept or broken? For example, a father promises his kids, if tomorrow is sunny, we will go to beach. P is tomorrow is sunny, Q is go to the beach. Promise is P implies Q. Promise is kept. So in the first case, the promise is kept. That is true. If tomorrow is sunny, didn't go to beach. If the father unable to take the children to beach, even though the day is sunny, the promise is broken. And tomorrow is not sunny, but the father taken the kids to beach. Promise is not broken. Promise is okay. It is there. Tomorrow is not sunny. Did not go to the beach. Promise is not broken. True also here. Okay, P implies Q being true because P is false is called vacuously true or true by default. Next, here contrapositive of P implies Q is negative P, negative Q implies negative P. Converse of P implies Q is Q implies P. Inverse of P implies Q is negative P implies negative Q. Okay, so these are the identities and these are the formulas. Okay, So I am sharing this particular presentation at the your group. Just to follow these examples, then you will understand everything. Similarly, the biconditional of P and Q is often of the form P if and only if Q is denoted by P double implied Q. It is true when P and Q have the same truth value, and it is false otherwise. Okay, so this is the example you can understand, which is self explanatory. Okay, so this is today's class, and any queries you can approach me. Thank you.